Assalamualaikum and selamat sejahtera. Okay, we continue with our lesson on electromotive force and internal resistance. Okay, last time we look at the difference between DGE or EMF and a potential difference. Okay, today we continue further how we are going to determine the EMF and internal resistance. So we are going to do one experiment. So what we need is a battery, a rheostat, ammeter, voltmeter, and one resistor is the 1 ohm or 5 ohm resistor, and also a switch, and of course connecting wires. So this is how we arrange the circuit. Okay, the battery connected with the voltmeter in parallel. Okay, then in series from the positive terminal go to the rheostat and go to the at the bottom of the rheostat goes to the resistor, ammeter, and back to negative terminal of the battery. Now we use the rheostat to adjust the ammeter reading until I equal to 0.2 ampere, and then you record the voltmeter reading as V and fill in the table. Okay, now you repeat the experiment with I equals to 0.3 ampere, 0.4 ampere, 0.5 ampere, and 0.6 ampere, and after that you plot a graph V against I. Alright. Now, so this is what we get from the experiment. Okay, 0.2, 2.85, 0.3, V 2.70, I 0.4, 2.6, and so on. And we plot the graph, and we get the best fit graph until it okay, we draw the line until it cross the y-axis. Alright, so first question, what can you say about the relationship between the potential difference across the cell and the current flow? Okay, so as I increase, what happened to voltmeter? What happened to the voltage? Voltmeter decrease. So the higher the current, the lower the voltage. Now, let's look at mathematics. So we know that the equation for the straight line is y equals to mx plus c. Remember, y refer to the y-axis, m is the gradient, x is the x-axis, and c is the y-intercept. Okay, and then remember we have the formula E equals to V plus I r, small r, and we rearrange V as the title, so we get V equals to minus IR plus E. And then we compare with the equation of y equals to mx. So what we get is V refer to y-axis, okay, I refer to x-axis, and minus r equals to the gradient of the graph, and the graph is minus, the gradient is minus, right? And E refer to the y-intercept. So we conclude that in order to calculate atau to find E, we look at the gradient, look at the y-intercept, and the gradient will give you the internal resistance R. Okay, so gradient is the internal resistance, and y-intercept give you the electromotive force E. Right? So look at what we get from the experiment. So the y-intercept is 3.0 volt, means that E equals to 3.0 volt. And we calculate the gradient. So how we calculate the gradient? So we draw the triangle. So we get 3 minus 2.4. And so this is negative. So we get 2.4 minus 3. And divide by 0.6 minus 0. So we get 1.0 volt per ampere, or 1.0 ohm. Okay, so this is the internal resistance. Volt per ampere is ohm, right? Okay, so the graph is a straight line. So from here we get E equals to V plus IR, from the what we learned last topic. So E equals to V plus IR. So we rearrange the V as a title. So we get V equals to minus IR plus E. Okay, so if the straight line is extrapolated until it cuts the vertical axis V, so we get when I equals to 0, V equals to E. So E is the DGE or EMF of the battery. So this shows that the potential differ across the terminals of the cell is the electromotive force when no current flows. So Yi equals to 0, V equals to the EMF. Okay. The internal resistance R can be determined from the gradient of the graph. So from the gradient we calculate the internal resistance. So for one question, so we have this graph. So first, what is the value of E? So E is the y-intercept is equals to 1.5 volt. And then what is the internal resistance? So calculate the gradient. So 1.5 minus 0.9 divide by 0.6 minus 0. So we get 1.0 ohm. Okay. Alright, so that's it for the EMF and internal resistance. Now look at examples of question regarding EMF and internal resistance. Okay, look at question number 1. So we have the circuit, dry cell with EMF 2 volt and internal resistance small r 1 ohm, and resistance big R is 4 ohm. So what is the value of the reading of the voltmeter? So we know the E, we know small r, we know the big R. We don't know the current, right? So we need to find the current. So we list down all the possible information that we have given. So E equals to R in bracket R big R plus small r. So equals to 2. Given 2 equals to I. I we don't know I, right? So 4 plus 1 equals to 5I. So I equivalent to 0.4 ampere. Now from that, you want to find the reading of voltmeter, that is V. So V equals to IR, 0.4 times 4, 4 ohm, equals to 1.6 volt. Okay. So now look at question 2. So we have a diagram, circuit diagram. Okay, what we have here is bulb M connected to battery. So what information? Voltmeter is connected. Okay, when the switch is open, the voltmeter is 6.0 volt. Open the switch, voltmeter 6.0 volt. And when the switch is closed, the reading will become 4.8 volt. Okay, so we have the information E, V. So what else? Okay, now what is the DGE? So DGE is when the reading of voltmeter when the switch is open. So that is 6.0 volt. Now V, what is if the resistance of the bulb is 8 ohm? So this refer to big R. Okay. So what is the current passing through? So we have the formula V equals to IR, right? So we know V, just now V is 4.8. We know R, 8 ohm. So I equals to V over R. So we 4.8 from here. Divide by 8 is the R, capital R, because the external resistance here. So we get 0.6 ampere. So C, what is the internal resistance? So we use the formula E equals to V plus IR. Okay, IR equals to E minus V. 6 minus 4.6, we get 1.2, right? So R equals to 1.2 divided by 0.6 from here. So we get 2 ohm. Okay. Okay, so next question, number 3. So again, we have another circuit diagram. So remember battery and voltmeter. So this is in parallel. So this will automatically give you the EMF when the switch is open. So what is the information given? Switch is open, 1.5 volt. Switch is closed, drop to 1.35 volt. So ammeter reading is given 0.3 ampere. So first question, EMF E equals to 1.5 volt when the switch is open, right? So 1.5 volt. Internal resistance, okay, we use the formula E equals to V plus I small r, right? Okay. and I rearrange. I got IR equals to E minus V, 1.5 minus 1.35 from here. So we get 0.15 divide by our I is given 0.3, so we get 0.5 ohm. And now big R, so V equals to IR, right? IR, so V is given 1.35, 0.3 times R, so R is 4.5 ohm. Okay, any question? Alright, so this is how you solve the problem. First, you collect all the information given, and then what you have to find, and then try to look at the which formula that you want to use, right? Okay. Alright, see you for the next lesson. Thank you. Bye. Assalamualaikum.